So let's go ahead and use these definitions in order to solve some problems and questions that we've got further down. Got problem number 7. If angle A complements angle B and the measure of angle B equals 31 degrees, what is the measure of angle A? Well, this is a pretty easy problem actually, because if angle A complements angle B, that means the sum of their measures is equal to 90. Well, we know that, and we're given that the measure of angle B is 31 degrees. So all we really have to do is solve this equation. Whatever the measure of angle A is, plus 31 degrees needs to equal 90 degrees. That's pretty simple. If we just subtracted 31 degrees from both sides, we would be able to get the measure of angle A, which is equal, therefore, to 59 degrees. And that's the answer to question 7. Measure of angle A is 59 degrees. Let's go to problem number 8. So problem number 8 reads that if A supplements B and the measure of angle B is 31, then what is the measure of angle A? Well, A supplements B is another way of saying that the measure of angle A plus the measure of angle B equals 180 degrees. And we're given that the measure of angle B is 31 degrees. So we could put that instead of measure of angle B. And then we have this equation we have to solve. The measure of angle A plus 31 degrees is equal to 180 degrees. Well, that's about as simple as the last problem was. All we have to do is subtract 31 degrees from both sides, and we will get that the measure of angle A equals 149 degrees. And that is the answer to this problem. Okay, so those were fairly straightforward and pretty much based on the definition of complementary and supplementary. Well, let's go on to problem number 9. Problem number 9 is a diagram, and we have to figure out the measure of angle 1 here. Okay, well, we're given a straight angle, right? We know that this is a straight line. So what the diagram is really telling us is that 117 plus the measure of angle 1 is equal to 180 degrees. That's sort of another way of saying that angle 117, the angle that's 117 degrees, and angle 1 are supplementary. So let's go ahead and solve this. We could subtract 117 from both sides, and we will get that the measure of angle 1 equals 63 degrees. And we're done. That is the answer to problem number 9. Now, problem number 10 is a bit more complicated. So we're actually given 4 unknown angles here that we need to solve for. Angles 1, 2, 3, and 4, we need to solve for their measures. And this is the first time we're going to use some of the properties of vertical angles. Okay, so we've got, and we're given 2 of the angles. One of the angles we're told is that let me name these lines. Let's call the horizontal line H and the vertical line V, just so we've got a way we can refer to these 2 lines. What we've got here is that V and H make right angles with each other. Well, we just saw a few moments ago that that means that V is perpendicular to H. Okay, so we've got a perpendicularity there. And in fact, every angle that V makes with H is 90 degrees. That includes this angle over here. So when you have 2 perpendicular lines intersect to form right angles everywhere they intersect. So angle 1 here is formed by the intersection of V and H, just like this angle over here is the one that we're given as a right angle. So we know already that the measure of angle 1 equals 90. So we've already got the first angle that we're looking for. Let's keep going. Well, I said this had something to do with vertical angles. And if you recall, vertical angles always have equal measure. Well, what's a pair of vertical angles here where we know maybe the measure of one of them, but we don't know the measure of the other? Take a moment and try to find them. Okay, you may have realized that we know that this angle has a measure of 47 degrees, and the angle vertical to it is angle 3. So, since vertical angles have equal measures, we now know that angle 3 has a measure of 47 degrees. So, we've got 2 out of our 4 angles already. That's pretty nice. So, let me write in here 47 degrees for this angle. So, we can remember that's 47 degrees. Well, what else do we know in this diagram? We said that V and H intersect to form right angles everywhere. So we've only drawn in 2 of those right angles. There's another right angle right over here. Okay? So that means that angle 2 plus angle 3 equals 90 degrees because it's a right angle. So we've got another equality that might help us here. The measure of angle 2 plus the measure of angle 3 equals 90 degrees. And we've got here that the measure of angle 3 is 47 degrees. Well, that sounds like it's enough information to maybe solve for angle 2, and it is. So let's go ahead and substitute in here 47 degrees. And we have this new equation, the measure of angle 2 plus 47 degrees equals 90 degrees. Let's subtract 47 degrees from both sides. And that gives us that the measure of angle 2 is equal to 43 degrees. Well, we've got that. So we've got measure of angle 1, measure of angle 3, measure of angle 2. That leaves us only needing to find out the measure of angle 4. Okay, but you'll see that's pretty easy to do. Once we know that 2 is 43, we know angle 4 is vertical to that 43 degrees, so therefore the measure of angle 4 has also got to be equal to 43 degrees. So now we have found the measures of all the angles. Let's write in 43 degrees over here. Let's write in 90 degrees over here, and of course 90 degrees over here. So now we've written in all of our degrees. Let me zoom in on this a little bit so you've got a way you can finish your diagram up. Make sure you've got the same thing that's written down here, because we're going to need it in order to solve the next 4 true and false questions. Okay, so for the next 4 questions, we have to use this figure to determine if the statement is true or false. Number 11, angles 1 and 2 form a linear pair. 1 and 2. Now let's take a look at 1 and 2. And let's draw in their non-common sides. Remember that 2 adjacent angles whose non-common sides form opposite rays is a linear pair. So does angle 1 and angle 2 form a linear pair? Their non-common sides would be this. This part of V would be the common side, and this would be their other non-common side. Are those 2 rays opposite? No, they're not. So therefore, it is false that angle 1 and 2 form a linear pair. What's another way we could have known that? Well, let's calculate the sum of the measures of angle 1 and angle 2. So the measure of angle 1 plus the measure of angle 2 is equal to 90 plus 43, which is equal to 133 degrees. Is that 180 degrees? No, it's not. So therefore, angles 1 and 2 do not form a linear pair. Let's look at question number 2. Angles 3 and 4 are complementary. So angles 3 and 4, in order for angles 3 and 4 to be complementary, the measure of angle 3 plus the measure of angle 4 would have to equal to 90. Is that true or not? Well, the measure of angle 3 we know is 47. Okay, so we'll draw that down here, 47. The measure of angle 4 is 43. And is 47 plus 43 equal to 90? Yep, it is. So therefore, it's true. Angle 3 and angle 4 are complementary. We already said it was false that 1 and 2 formed a linear pair. Let's now go down to number 13. And let's read number 13. The measure of angle 1 plus the measure of angle 2 plus the measure of angle 3 equals 180. So let's go back to our diagram. So angle 1 plus angle 2 plus angle 3. Well, what is that? That would be this whole combination, right? If we add these three angles together, angle 1 plus angle 2 plus angle 3, we have this whole angle, which is obviously a straight angle, right? And a straight angle is equal to 180 degrees, so this is true. So it is true. 13 is true. And let's look at our last true and false question. Angle 2 and angle 3 are adjacent angles. Are they adjacent angles? You bet. Okay, they both have the same side right here, common side. So they are adjacent angles, and that is true. In the next video, we are going to do some constructions of perpendicular lines.